A very good afternoon and warm welcome to all the attendees and panelists. We all know the biggest challenge every food processing industry faces today is the lack of advancement and innovation in its manufacturing practices. Now, to bridge this upgradation gap, we at Neologic engineers decided to present an emerging food tech webinar series where we will talk about the cost-effective food processing automation, applications of top-notch food machineries and technologies, then current trends and future directions in the food processing sector and much more. So we have been conducting such webinars since last 3 years, and in the 19th webinar of this series today, we will be talking about advanced citrus fruit processing technology. Now today's webinar is particularly very special as it is being hosted in collaboration with Fratelli Indelicato, Italy. Let me introduce today's speakers. Our first speaker today is Mr. Sri Krishna Ozarkar. Born in middle-class family in Nashik, he completed his entire education in Pune by completing mechanical engineering from Pune University in 1987. After spending a few years in SKF, he joined Alfa Laval and worked in project planning and execution in the dairy beverage sector of the manufacturing department. Then he started his entrepreneurial journey by starting his own firm in 1996 and eventually merged his business areas with Neologic engineers. He has been designing, supplying, installing processing lines for FNV fruits and vegetables since the year 2000. He has been instrumental in developing few of the machineries in India as an import substitute under Make in India scheme. Professionally, a hardcore technocrat, engineer and valuer, his interests are reading books and listening to Indian classical music. Welcome, Mr. Sri Krishna Ozarkar. Our second speaker today is Mr. Carmelo Indelicato. Born in Catania, Italy, Carmelo graduated MS in Mechanical Engineering in 2005 from the University of Catania, Italy. In 2008, he completed his PhD in Structural Integrity Engineering at University of Catania. Carmelo then immediately joined the French company Alstom as a mechanical integrity engineer in R&D division for the turbogas engines in Switzerland. In 2011, Carmelo joined the family business Fratelli Indelicato, founded by his grandfather in 1946. He represents the third generation of the family. Since joining the company, Carmelo has supervised the realization and commissioning of many processing lines around the world. So, ladies and gentlemen, let me present our first speaker today, Mr. Sri Krishna Ozarkar. Over to you, sir.
Yes, good afternoon, everyone, and welcome to this 19th edition of Emerging Food Technology webinar. So today's topic is a bit niche topic. As the topic suggests or the heading suggests, it is advanced citrus food processing technologies, specifically also related to India. India, as everybody knows, is growing well in the food processing sector over last, say, 1 or 2 decades. And this becomes also an important topic for our people to understand how the technology is developing in citrus fruit processing. One short disclaimer, the entire technology we are going to present is based on our years of experience. It can be something different from what others are supplying, but this is what we feel as one of the best technologies that is going to offer you the desired product quality and desired product level. So, as Nikhil introduced Carmelo Indelicato represents the company called Fratelli Indelicato, who are our partners in India for this particular citrus and tropical fruit processing technology. Let's try to understand what are we going to cover in this particular 45 minutes session. We'll have a 15 minutes interaction about the question answer or any queries you may have. So first we will be understanding about the Indian scenario about the citrus fruits. So what are the kinds of fruits which are available in citrus category in India? Which are the areas in which these are grown? Which are the upcoming or growth areas for this particular fruits? And also what could be the opportunities for Indian people to process into this particular citrus fruit processing? Second, which we are going to cover is typically understanding of what is the citrus fruit processing. Third, we will understand what are the latest trends and technologies which are in the citrus fruit processing. Extraction of citrus oil is also an important topic, because when we say about citrus processing, the citrus oil processing becomes an important aspect of that particular processing. So that we will be covering. And at the end, we will have a recap of what all we covered. And of course, after that, we will have the question answer session. So let's try to have an overview of the types and growing areas in India about this. So the typical Mandarin orange, which is the technical name is Citrus reticulata, is most common among the citrus fruits grown in India. The Mandarin orange is generally known as Santra in India and is native of Southeast Asia. It is a rounded, usually thorny evergreen shrub with small tree that can grow up to say 15 to 25 feet tall and produce fruits up to 3.5 or 4-inch diameter, resembling to orange. Sweet orange is also generally called as a Mosambi, is also a typical another type of citrus fruit in that. Oranges are known to be sweeter than the other varieties, and Kinu is more sour taste than, while the Mosambi is having the mild sweet taste in the nature. This citrus orange occupy around 40% of total area under citrus cultivation in India, all these types. And the most important aspect in the species are the mandarin, which is Citrus reticulata, sweet orange, Mosambi, what we call, or Citrus sinensis, and acid lime, Citrus aurantifolia. These share around 41, 23, and 23% in all the fruit produced in the country. The important Mandarin orange varieties cultivated in India, Nagpur orange or Nagpur Santra, which is the most famous variety in India, Kurk Santra, Khasi Santra, Mudkhed, Srinagar, Butwal, Dansi, Kara, which is from Abhor, Punjab area, SZ Incom, which is a typical variety developed by NHB, that is National Horticultural Board, which is very well known for its improved plant growth, yield, as well as the fruit quality. Then Darjeeling Mandarin, Sumitra Mandarin, Seedless 182. These are some of the types of varieties which are typically grown in India. The Kinu is also one of the citrus fruits which are grown in India. It's more largely cultivated in northern India, and Punjab holds the maximum share in Kinu Mandarin processing area in the country. But the other states also include Haryana, Rajasthan, Madhya Pradesh, Himachal, and Jammu and Kashmir. Kinu has a high yield Mandarin hybrid, which is Citrus nobilis and Citrus delucia, scientifically known as Citrus reticulata blanco. This hybrid citrus fruit actually offers several advantages over regular oranges. It is known for its higher calcium content. It is said that the Kinu can have actually 2.5 times more calcium than the rest of the citrus fruits, typically in Indian varieties. And it is good for heart health, cholesterol balance. Additionally, Kinu is the best source for vitamin C and dietary fiber. A typical citrus belt of India, you can see citrus growth all over India, but typically if you see the northern east region, which is called as the citrus belt of India, which is very upcoming region in citrus processing, and we'll have a lot of fruit processing or citrus processing plants in the coming years over that area, has got a remarkable diversity in that particular citrus species. This belt comprises of Assam, Meghalaya, Arunachal Pradesh, Manipur, Nagaland, and Mizoram as the citrus belt. And this particular region has actually 52 varieties comprising of 17 citrus species and 6 hybrid species. This is a statewide production and productivity of citrus. This data has been taken from National Horticultural Board and Ministry of Agriculture, Government of India. This data relates to 21-22, so there will be upgradation in the coming years on this data as well. And this will give you area of plantation, area of production and productivity, metric tons per hectare, that all is given. And if you can see, Madhya Pradesh has got one of the highest, along with the Telangana and Karnataka, productivity in metric tons per hectare. These are state-wise growing belts. Like typically we say Nagpur Santra or Nagpur Orange. Maharashtra has the region of Nagpur, Akola, Amravati, and Wardha, that typical belt where most of the oranges will be grown. And then in Rajasthan, we have Jhalwad, Kota. In Karnataka, we have Chikmagalur, Kodagu, Hassan, Bijapur, Gulbarga, and Bagalkot. Madhya Pradesh, we have a couple of districts, Assam, Nagaland, Mizoram, Tamil Nadu, West Bengal, Orissa, Meghalaya. And of course, like we mentioned for Kinu, Punjab, Abor is the maximum area where these kinus are grown. So let's try to understand what is citrus fruit processing. So citrus fruit processing will have a typical juice extraction and then juice concentration. This juice concentration can be into aseptic juice, or this juice concentrate can be frozen concentrate orange juice, what we call as a FCOZ. So it can be ACOZ, aseptic concentrate orange juice, or it can be FCOZ, which can be frozen concentrate orange juice. Then we'll understand about debittering, what is debittering in citrus processing or deacidifying. We will understand the pulp recovery, essential oil recovery, waste processing or third quality citrus recovery. We'll also understand about pulp wash, what is the pulp wash system, and then we can understand that the systems can be running up to 40 to 60 tons per hour. The citrus fruit is a source of valuable product, and that can be the essential oil, that can be the juice concentrate. The peel waste is also used in cosmetics, so there are a lot of applications which can happen from the peel, orange peel or orange peel powder as well. Then the D-limonene, the cloudy juice, the pectin which is created from the fruit peels, citric acid, fiber, all these products we will be discussing again at the end. Let's try to understand the typical process flow. So we will have the fresh citrus receiving and storing. Storing because the receiving of the citrus may be continuous or may not be continuous, and we should have a buffer in order to feed and run the machines continuously. Then fresh citrus distributing, so the distribution to conveyor, distribution to the grading should be constant, so that distribution has to be proper. Then we will understand about rasping machines for the juice extraction, oil extraction, and also the inline juice extraction, refining about the juice. We will have traditional juice extraction systems and refining sections. We will understand the juice stabilization, blending or debittering or pulp addition and deacidification. We'll understand how the automation works in the entire system. What is the concentration section, means how you are going to concentrate the orange juice or citrus juice. Then how this juice is going to be filled, whether it is to be filled aseptically into aseptic bags or whether it is to be filled as a frozen orange concentrate juice. Then pulp recovery and aseptic packing section. What is going to happen in the pulp wash, whether it should be 2-stage or 4-stage pulp wash, and how we can value add with the pulp in the entire juice process. We'll be also covering the essential oil recovery, that is important aspect of any citrus fruit. Then the waste collections or the third quality juice recovery, that also will be discussed. And of course, for any food processing plant, it requires a CIP station, that is cleaning in place. So we'll understand about CIP process and why it is required in this particular scenario. So the typical process flow, we will receive the fruits with due quality analysis done. We'll try to analyze the size, the initial bricks, the initial acidity of the fruit, the juice yield, the defects, all this analysis will be done. Then this will be going for the vehicle weighment after receiving and QA analysis. The vehicle will be weighed and it will be going on to the unloading ramp for either dry unloading or wet unloading. Then the sorting and grading. We will sort and grade the fruits, the defected fruits, small fruits, leaves, straw, or stems, stones, whatever are coming along with the fruits will be taken out. Then these will be stored in the either in bins or in silos, or can go directly for the processing. Then we will have the fruit washing. There could be 1 or 2 stations depending on the requirement. Then the fruits after washing and brushing will go for sorting and grading, typically for physical damage and foreign matters. Then they will go for sizing because the cup extractors will typically require different sizes of the fruits. So it will go for sizing. Then extraction by the cup extractors for the juice, oil, and waste as well. Then it will go for multiple effect evaporator. The number of effects, of course, will depend on what is the quantity or what is the capacity we are processing. Then there will be a pulp separation from the juice, which is through the centrifuge. We will also understand about debittering, which is going to be followed by pulp addition, and the evaporation final stage, and blending and packing. This is all what we are going to cover. So this is a typical process flow for the entire citrus processing line. So I request Carmelo to explain this onwards. Over to you. Over to you, Carmelo.
We have here a typical schematic layout of what a complete citrus plant should look like. You have a first section, fruit unloading. So the fruit will arrive typically in trucks to the plant, will be discharged. We will later see if it's a wet discharge or dry discharge. Then there is a grading section, a balance bin in order to stabilize the flow inside the production area, washing of the fruit, grading, sizing, juice extraction, and then juice finishing, and later on, if you're producing concentrate juice, then you have the evaporators. Otherwise, if you're producing not from concentrate juice, the juice will go to a different path. And regarding the oil, the emulsion and frit will go through a finish and then through the separators. And you see the first part is the fruit extraction and then the refining of the juice and the pulp. This here is a very, very simple and schematic flow chart of the process only regarding the extraction section of the oil plant. So as I tell you, the fruit will arrive in trucks, it will be discharged, washed, brushed, and then it will be routed to the actual extraction section of the plant. In our line, we install a dedicated oil extractors, particularly when processing hard fruit like oranges, lemons, grapefruit, or lime, in order to enhance the yield of the extraction of essential oil. So the fruit will be routed into our polycitrus oil extractor. From this machine, you have two outlets. One is the mixture of water, essential oil, and small particle of peels that will go to the oil recovery unit. Then the second outlet are the oil fruit, still firm, that will go to the juice extraction section. So the juice will, the fruit will be sized and then routed to our new cup juice extractor. Here you have 4 different streams. The first one is whatever oil is left in the fruit from the polycitrus, you can recover here. And this stream will be joined together with the emulsion coming from the polycitrus. The second stream are the outer peel, the flavedo, which is routed to the waste or to other units that can extract value from this waste. A third stream is what is inside the strainer of the machine. So the membranes, the core, some pulp. And the fourth and main stream is the pulpy juice, of course. This juice will be routed to a finisher, which will reduce the pulp content to a level of about 7% in volume. And then you have here at this point the juice ready for further processing. If you are producing not from concentrates or natural juice, you can just take the juice here, pasteurize it, and pack it. That's ready for natural juice selling. The pulp coming out from this finisher can be routed to a pulp washing unit. This pulp will still have some bricks in it, some solids, valuable solids. And the pulp washing unit will help you to recover these solids and to get some liquor with bricks that can be concentrated and sold as a concentrated juice. From this chart, you see on the left side that the membranes and pulp from the strainer still also contain some juice and bricks, and we can extract that with a screw press, and then a second finisher that we recover this secondary juice, which is slightly less quality than the primary juice, but still valuable for the concentrate production. Here you can see some example of wet unloading system. So the trucks will unload the fruit into these pools with water. You might even use chemicals to proper clean the fruit. And then the fruit is ready to go inside the production area. This is a typical layout of one of our lines. In particular, this one can process up to 30-35 tons per hour of citrus, any kind of citrus from lime to oranges, lemons, grapefruit. In case of soft fruit or easy peel fruit, the layout is a little bit different because we will bypass the dedicated oil extractor. And you have three main sections. In green, the receiving and preparation area. In orange, the oil extraction section with the two polycitrus machines and the finishers and the centrifuges. And in red, the juice part with all the juice extractors, the sizer and the finishers for the juice. Here you can see an example of a brushing machine. Typically, these machines are equipped with several array of nozzles in order to give you the possibility to use not only fresh water but also at the same time chemicals to properly wash and rinse the fruit. Here you can see other examples. And then this is where the sorting and sizing of the fruit happens. And once you split the fruit by size, each size is then routed to the proper cup extractor. Now let's see what are the latest development in the juice processing technology. As you probably all well know, there are on the market since many decades a lot of manufacturers who build this kind of machines, this kind of cup extractors. This machine was at the beginning developed in the US in the late 40s or beginning of the 50s. And ever since, many other companies have just taken this technology and made their own version, although not bringing in some major innovation. What we did is we took a different approach. Although the working principle of the machine is the same as the others, so you have the interlocking cups that squeeze the fruit, we tried to simplify a lot the architecture of the machine. And this machine in particular has less components, less mechanical components than the others, which means for the end user, an easier operation with less maintenance. And also very, very importantly, there is, given to the peculiar characteristic and architecture of the machine, there is no risk of contamination of the product with lubricants, because all the other manufacturers have very complicated mechanical transmissions in this machine to drive all the motion which is going on. And all these mechanical components requires lubricants. We simplified a lot the machine. I can go into details later if you want. And this allows us to reduce or completely eliminate the risk of contamination of the product with the lubricants. The machine can run at 120 strokes per minute with 5 cups, which means 600 fruit per minute. It can extract the juice and also the essential oil, although given the cup technology, itself. It's characteristic of this kind of machines. The yield in essential oil is lower with this machine that you can get with the rasping machine. The machine requires sized fruit to work properly, to give the proper yield, and has an installed power of 17 kilowatts. We are selling our machine, not leasing at the moment. It's entirely made of stainless steel. The CIP system is embedded of the machine, and it can be configured with different cup size, different strainer size, different mesh of the strainer, different holes of the strainer. This is the general working principle of the machine of any kind of cup extractors. So the fruit will fall into the lower cup, and the upper cup will go towards it, will go down and will encounter the fruit. And when it does so, it will cut two openings, one on the bottom of the fruit and one on the top of the fruit. And by continuing going down, the upper cup forces the juice going into the strainer, and therefore the juice will be collected later on and going together with the juice of other extractors. Whereas the peels is forced to go on the annular region, which is created between the upper cup and the upper knife. And during this operation, is going through this annular region, the oil cells are broken and the oil can be collected and then further processed. And these are the technical data of the machine. So the input, the machine can handle 3.5 tons per hour of citrus. In case the essential oil is recovered only with this machine, it requires about 1,500 liters per hour of water. In case you have upstream the oil extractor, the polycitrus oil extractor, the water required here is much less than half. And as I told you before, the output are the primary juice that will go to a juice finisher, the emulsion of water, essential oil, and fruit that will go to emulsion finishers and then to the centrifuges. And then you have the peels, the flavoedo, the rags and membranes, and the exhausted pulp that can go to the waste or to, let's say, waste treatment processes downstream. These are some pictures of the machine in a processing line here in Italy. And you can see already from the pictures, the machine is much cleaner. You can see less mechanical motors or transmission exposed compared to what you see on the market at the moment. After the juice is extracted, it will go into a finisher. We propose a two-stage finisher. The first stage is equipped with a mesh of about 1.2 or 1.5 millimeters. This will allow you also to recover from the first stage cells and pulp of good quality that can be sold as a product. The juice then will flow into the second stage, which is equipped with a 0.5 millimeter. And here is refined till the desired amount of pulp content. This is our screw press to treat the membranes, the core, and the pulp to recover some extra juice. And then an opportunity that you have is to collect the pulp coming from the finisher, which, as I told you before, still contains a lot of sugar of Brochures, and try to extract these Brochures in order to increase the overall yield of your plant. And this system is commonly called the pulp washing system. We offer a 4-stage pulp wash unit, which means that you will have 4 finishers working in a counter-curing system. We are proposing 4 stages rather than 2 or 3, because this will reduce the amount of water that you will need to add to the pulp in order to obtain, to recover all the soluble solids that are still in the pulp. Consider that the ratio water to pulp in a 4-stage system is on average 1.2, 1.3. If you decrease the number of stages to 3 or to 2, this ratio can go up to 2. So it means that with 4 stages, for 1 ton of pulp, you need to add 1.3 ton of water. With a 2-stage system, for 1 ton of pulp, you need to add 2 tons of water. So everything is that you have higher water consumption, less sustainability, you need to have more tanks or bigger tanks and so on. And this is the very simplified flow chart of this pulp washing system. As I told you, it's a counter-current system, which means that the pulp will, from the first finisher, from the primary finisher of the juice, will be pumped into the roto finisher number 1. The water will be added to the last finisher of the system, so roto finisher number 4. And from this last finisher, you have 2 outlets. One is the exhausted pulp that can go to the waste, and one is the liquor that will start to enrich in brixes and will go from the roto finisher number 4 up to the second to last roto finisher number 3, again up to the roto finisher number 2, and so on, up until reached the roto finisher number 1, at the outlet of which you will get the strong liquor with about 5 to 6 bricks that can go to the evaporator. I hand back to you, Parag.
Yeah, thank you. So while Carmelo was, you keep on the slides.
Yeah, sure.
Yeah.
Can you see it?
Not yet.
Okay.
Yeah. So while Carmelo was talking about the pulp wash and pulp separation and other things, one of the important aspects in the citrus processing is separation of high density pulp from the juice. And that is typically done by a typical model of separator, which separates the continuous stream of concentrated pulp or high density pulp, then a continuous stream of juice, and also the wastage. So all this is possible with a specific model which we can use for citrus processing. So we need to understand that the rest of the models of the separators may not be actually typically used in this particular application. So there has to be a typical application depending on the capacity, depending on the pulp content. We have to choose a model and we have to select and engineer that model for particular application. Then what we were discussing about debittering, like we mentioned, there is a limonene content in the citrus fruits, and that gives you the bitterness. So that bitterness acceptability, like you see in the slide just now, the outlet limonene content has to be less than 5 ppm. So that is done by this particular system. This is entire system in stainless steel, and the inlet could be as high as 15 or 35 ppm, and the outlet has to be maintained between 3 to 5 ppm to have the less or acceptable level of bitterness in the juice. Also, the pulp which is separated from the earlier separator we were discussing, if it is directly going without separator into the debittering unit, it can actually clog and choke up the debittering unit. That's why the separated pulp will be separated. The lesser pulp content juice will go to the debittering unit, and then the debittering process will happen, and further it will go for processing. Next slide, please. Yeah, then after this, we will have the evaporator, or the pulp addition can be done prior to evaporator, or pulp addition can be done after evaporator, depending on what kind of pulp addition we are looking for. The evaporator could be multiple effect. It could be 1, 2, 3, 4, or even up to 7 stages. That will depend on the capacity. The concentration from the initial bricks, maybe 9 to 12 or 13, can go up to 65, 70 bricks as well. So based on the initial fruit level, the concentration will happen, and that will give you the capacity of the entire project or entire line of the project. And this is a falling film evaporator, unlike the other tropical fruits which we process like mango, guava, or tomato, which require forced circulation evaporator. This is using a thin falling film evaporator. Next slide, please. This is a typical process flow of the evaporation with the inlet juice bricks between 8, 10, or 12, and the outlet bricks at the outlet bricks is also maintained at 65 to 72, depending on what kind of concentration we are looking for. These stages will not go into detail because this is a niche technical topic, and if we cover all this, it will be exceeding our 45-minute scheduled time. So whomsoever is interested in knowing the entire process flow, we can have a separate discussion on that. Let's move to next slide, please. Yeah, again, the second stage of evaporation after the pulse separation and debittering. Yes, so all these stages and also can be discussed in detail once we have a sufficient time on that. Next slide, please. The concentrated pulp can go for aseptic sterilization if we are looking for aseptic concentrated orange juice, that is ACOJ, or it can go as a frozen orange concentrate juice, FCOJ. So depending on what is the kind of requirement we are looking for, it can have the aseptic sterilizer and aseptic filler, which we will see in the next slide. Yes, the aseptic filling after aseptic sterilization is filled into aseptic bags, which can be of 5 kg, 20 kg, or it can be even of say 220 kg or 1000 kg, which has got a shelf life of 2 years. Next slide, please. There is a requirement of blending. So depending on my season, depending on the time when I'm processing, the pH level acidity can vary from fruit to fruit. And in order that we supply a constant supply or constant quality of the concentrated orange juice with a typical acidity level maintained, we need to blend, and that is why that blending section is also required. Next slide, please. And then, of course, we discussed about frozen concentrated orange juice. So this is a non-aseptic filler put for the filling of frozen orange concentrate juice, which will be stored at -18 to -20. So there are few people who prefer frozen concentrate orange juice, or there are few customers who will prefer aseptic concentrated orange juice. So depending on that, we can have that facility, whether it can be aseptically sterilized and aseptically filled, or whether it can be only filled in the frozen concentrated orange juice, FCOC. Next slide, please. Yes, peel oils is also important aspect. In fact, it is one of the most important aspects in the entire citrus processing. So, Carmelo, you can cover this particular topic for next few slides.
Yeah. Okay, thank you.
Yeah.
So, as you know, the essential oil for citrus, particularly lemons, lime, grapefruit, is very valuable, and it's a very important source of income for all the fruit processors. In this slide, you can see a slice of a citrus fruit, and you can see where the oil is located in the fruit. It's just on the outer part of the peel, in those oil cells or oil glands. And each citrus variety has its own characteristic, its own flavor and taste for the oil, and each one of them has a different use that can go from cosmetic, perfumery, pharma, food ingredients. And here you have a list of all the main citrus varieties with the main essential oil characteristic. The traditional and standard process flow of how to recover this oil is already well known. So you remove the oil from the fruit, which whatever technology you have at your disposal. Then you have this mixture of water, essential oil, and particle of peels that will go through a finisher. From this finisher into a tank that will feed the first centrifuge. This centrifuge will separate most of the water from the oil. This enriched emulsion, which is mostly oil, will go into a second centrifuge that will make the final separation and will give you the pure oil that will go then to the storage or winterization unit. The water which will come out from the first centrifuge will be pumped into a decantation tank where this water will stay for a few minutes in order to settle down all the remaining solids, and from there is pumped back to the extractors. So it's a semi-closed system. The water is continuously recirculating during the operation. What can happen is that after a few hours of operation, the pectins level in this mixture will start to increase too much, and this will reduce the efficiency of the centrifuge. And in order to avoid the system, you drain a little bit of this water from the decanter and add back some fresh water. Typically, it can go up to 20–25%. So that's why I was saying that it's a quasi-closed system. And this is a schematic flow chart of our current system. So you have both technology working in cascade. You have the polycitrus M15, which is the dedicated oil extractor, which is where the main oil removal happens. Consider that with this machine, you can take out up to 85–86% of the total oil content of the fruit. Then the mixture of water, essential oil, and fruit will go to the emulsion finisher. Here we get rid of the solids, and then we hand over the product to the separators, to the vertical high-speed separators. And the water, as I told you before, will go back to the extractors. Whatever oil is left in the fruit and is left there because maybe you don't want to remove completely into the polycitrus because you want to preserve some firmness in the fruit, that oil can be recovered in the cap extractors. And the emulsion of water, essential oil, will be joined together with whatever is coming from the polycitrus M15. This is our oil extractor, the big one in our range, the M15, as I told you. The capacity of this machine is 10 tons per hour of lemons or lime and 20 tons per hour of oranges or grapefruit. And underneath the machine is the oil finisher, the emulsion oil finisher. These are some pictures of the inside of the machine. The key elements are the 6 counter-rotating rollers, which are coated with some rasping sheet. These are the rollers that actually mechanically scratch the surface of the fruit, releasing the oil. And then there are those paddles that move the fruit forward in the machine. And the 2 key parameters of this machine are the speed of both the rollers and the paddles. According the fruit hardness, according the fruit ripeness, you will adjust these 2 parameters in order to obtain always the optimum amount of rasping on the fruit. And these are some pictures of the fruit inside the machine. And once you have this mixture, it will fall by gravity into this finisher, and this finisher will remove the solids from the emulsion. And you can see on the right-hand side the waste coming out of this finisher. You can see it looks like crumble bread. There is also a video. You see how the peels, the fruit comes out from this front cap. It's pretty dry, so which means that you have no oil left in there. And this will go to the waste. This slide, on the other hand, explains to you how the oil is extracted in the cap extractor. And by the way, in case of soft fruit, or let's call it easy peel fruit, like some mandarins, in that case, you cannot use the polycitrus M15 because the risk of destroying the fruit is too high. So in that case, you bypass those oil extractors and go directly into the cap extractors and let them recover whatever oil they can. Also here you have some water which is injected into the upper cup, and this water will wash the fruit while the peels is going up in between the knife and the teeth of the cup. And this water will then collect the oil and then will go down to the root to the finisher. And after the finisher, you have, of course, the two high-speed vertical separators. This slide here is very important because this summarizes, behind this slide, there is a lot of technology that summarizes what's going on. This is the latest development to try to give value to the waste. We saw in this presentation the essential oil extraction part, the juice extraction part, but consider that in a typical citrus processing plant, you have 50% of juice, a few percentage, very little of essential oil, and almost 50% of waste. This is waste that still have a value. And the moment you reach a certain capacity, and this value is about when you are above 20 tons per hour, let's say that, let's put this boundary, above 20 tons per hour, it makes sense to look for solution to extract value from waste. Also because at this moment in the world, there is a huge demand for certain substances which are extracted from citrus peels in particular. So once you have your peels, what you can do with that? You can process that and you can extract several byproducts. First of all, you can extract D-limonene, which means basically essential oil. In those peels, you still have some little quantity of essential oil that can be extracted. And this D-limonene is a natural substitute for very polluting substances like benzene or toluene. So there is a huge market for this particular product. From the peels, you can extract cloudy juice. Cloudy juice is a juice with some turbidity and some structure, high pectin content, which is the base upon which the soft drinks are prepared. You can also prepare the peels for pectins production. So you can then export your dried peels to the pectins producers worldwide. Or you can recover citric acid and fiber. And the very interesting thing is that the technology we developed allows you to obtain all this product, using some innovating dryers with some energy recovery system embedded, which allows you, with the same amount of energy that you use to make your concentrate, you can also obtain these streams of value. And this is a solution that we are, at the moment, we developed in the last couple of years. We have some projects going on with this. And at the moment, I think we are the only one able to provide you a turnkey solution of this type.
Yes. So let's have a recap on what we have covered till now. So first we understood about the different varieties India has, different regions where all the citrus fruits, mandarin, Indian orange are grown. In fact, we also covered the quinoa. So understanding the types and varieties of typical orange or citrus fruits which are grown in India, the areas where they are grown, what is the productivity per hectare output or the productivity also we covered in few slides. We understood on why we should process and how we should process about the citrus fruit processing. Then we also understood the latest trends and technologies in citrus fruit processing. And then we covered the citrus oil extraction, which is a very small percentage but very important aspect of any citrus fruit processing. So this is what we have covered till now. Next slide, please. Now it's time for the question and answers. So Nikhil, you can take up question one by one. Either me or Carmelo will answer them.
Yes, sure. So this particular session is parallelly live on LinkedIn as well. So we have received one question on LinkedIn from Mr. Aniruddha. So he's asking, what are the key parameters you monitor during debittering process to ensure both efficiency in limonene removal and retention of sensory quality?
Okay. Carmelo, you want to answer that?
Yeah. So first of all, at the input of the bittering unit, the key parameters that must be monitored are the pulp content in the juice, which should be below a certain amount in order to avoid clogging of the system, and also the oil content in that juice, because this can risk to pollute the raisins quickly, and then they will not absorb any more limonene. So these are the two key parameters. Once the juice falls within the range prescribed in terms of pulp content, residual oil content, bricks, and so on, then the bittering unit will do its job. Because of course it will be dimensioned properly so that the retention time is properly calibrated in order to not to change organoleptic characteristic of the juice and so on.
Okay. Nikhil, next question.
Yeah. The next question we have received from Mr. Siddharth Moghe. He's asking how much should be the minimum volume of wastage to go for further processing to D-limonene or pectin, and how much should be the input fruit quantity?
In terms of fruit quantity, once you process more than 20 tons, 15 tons per hour on at least 10-hour production, then you should look, then the project is economically feasible. Below that level, then it's difficult. You can see that with 15 tons per hour of fruit, of fresh fruit, you will get about 7.58 tons of waste that you can process.
Actually, higher the better. So higher capacity
Of course.
will increase the viability of processing. Yeah.
Of course. 15, 20 tons is the bottom part of the range. But of course, once you go up to 30 tons or 40 tons, then it's a must to go for this kind of solution.
So Siddharth, I believe you have understood this particular threshold. As far as the capacity of the plant is considered, see, there is always a threshold capacity below which the plant viability becomes difficult. There could be higher sizes, but there is a certain capacity, what we call as a threshold capacity. And as everybody knows in food processing, if I am processing, say, 10 tons per hour and somebody is processing 20 tons per hour, the equipment price or the initial equipment capital expenditure doesn't become double in that case. It varies only maybe 20% or 25%. So the people who are processing at a higher capacity have lesser overheads or lesser cost per kg conversion. So that is how that threshold capacity, understanding the threshold capacity in Indian scenario is very important. And that's why we always advise that, say, somewhere around 10 tons minimum should be there, because then you are going to get, say, 5 tons of juice. 5 tons of juice when concentrated, say, 5 times or 6 times, it is going to give you output of, say, around 1000 kgs, 900 to 100, 1000 kgs. So that is why this threshold capacity is very important.
Yes. On a similar note, we have received the same question on threshold capacity recommended for Indian market in GNU belt. I think this answers the same.
Yeah, so not that we cannot give you a very smaller capacity plant. We will advise that the financial viability will be after a certain amount of capacity. Yeah.
Next question is from Mr. Akash Dwivedi. What are the key microbial hazard in citrus fruit processing and how can effective sanitization protocols mitigate the contamination risk?
Carmelo, you want to answer or should I answer?
I lost the first part of the question.
Yeah.
What are the key microbial hazards in citrus fruit processing and how can effective sanitization protocols mitigate the contamination risk?
No, Parag, if you can, yeah, please.
Yeah. So typically for every fruit processing, we need to follow a certain set of standards or set of parameters while we process, while we design the entire machinery. And typically for citrus fruits, the parameters are different than the rest of the say for mango or guava or tomato. So these parameters need to be specified. These parameters need to be considered while we are designing the machine. And of course, while we are designing the machine, whether the entire product or entire water, everything is getting drained or not, whether it is hygienic or not, and entire the CIP process, all the CIP process, whether it is effective in a certain amount of time, that has to be designed properly. And this, of course, we will answer you offline because this requires a detailed answer to be given.
Okay. There is another question from Disha. Can essential oil recovery for winterization be further optimized for niche applications? For example, pharmaceutical grade extracts.
Yes. That particular optimization is done after the oil is recovered. Once you have the pure oil,
Yeah.
then it can be further processed in order to meet the parameters or the requests from pharmaceutical industry. But normally, this is not done by the processors. So the processors sell the oils to other companies which are specialized in that, because you need then more equipment, more expertise, different expertise to do so. So
For those people in pharma or cosmetics, our peel oil is the raw material.
Exactly. Then the oil becomes the raw material of other people, of other companies.
Okay.
Yeah, there is one more question from Manoj, that in terms of blending, how do processors standardize juice characteristics despite regional and seasonal variability in citrus raw material in fruits?
See, the product which is processed, suppose I have a season of say 30 days or 45 days, and I have processed the product say after 1 week, 10 days or 15 days, and I have stored it as a FCOZ, that is frozen orange concentrate juice. At the latter part of the season, if the uh, pH level acidity is changed, I need to maintain the pH level while I'm giving it to the customer, and the requirement could be unique or requirement could be different. So what I do, I take back the original FCOZ, I blend it with the new juice which is processed, and then I reprocess it and further give it for the frozen concentrate orange juice. So this is the way of blending which is required to be carried out. It could be FCOZ or it could be ACOZ. So both the cases, the blending may be required in order to maintain what is to be given to the customer.
Okay. Thank you. There is one more question from Mr. John, that he is asking, given the growing demand of clean label and organic products, how adaptable is the current processing line to organic certified products?
Yeah, perfectly adapted. What is important is that when you stop processing the traditional or the regular product, the regular oranges, and you want to switch to organic, you run a clear, a proper sanification of the whole line, and then the machines are ready to receive the organic product. But there is no difference in between the two lines.
Yes. One more question we have received from Mr. Shavez Qureshi. How efficient is inline cup extractor and are there any alternatives to that?
Yes, there are alternatives. The yield can go up 50%. The main characteristic of the inline cup extractor is that you have less risk of contaminating the juice with the essential oil. And so you have a less bitterness in the final taste of the product. And this is very, very important for not from concentrate juice. When you are producing concentrate, also the traditional system is very, very effective. And the system that we developed already in the 70s is already effective, because in any case, whatever oil is left in the juice, you can easily remove it in the evaporator. So at the end, when you have frozen concentrate orange juice, whether it comes from the inline cup extractor or from the traditional system, the difference is not so important as if in the NFC case. So the traditional systems gives you also more flexibility because it doesn't require sizing the fruit. So the line will be much easier to operate, much simple to install. I mean, in theory, it's a good way to start a plant. And then as soon as you get traction, you start having income from your juice, you can also think to the cup extractors to be put in parallel. There are alternatives. Just to give you an example, in Argentina, for example, what some producers are doing is they have a line with the cup extractors that will process only fruit of a certain size. So just to give you an example, from 45 to 70 millimeters. All the other fruit is routed to the traditional system. So whatever is smaller than 40 mm and bigger than 75 mm is collected together and go to our traditional juice extractor, because they are mainly interested in concentrate. So it doesn't make sense to have a line with 17 extractors, cup extractors. Just one traditional juice extractor can do the job. And for concentrate is absolutely fine.
Carmelo, I think we also need to tell people that depending on the fruit variety, if the fruit variety is of loose skin, the selection of the extraction machine will be also depend on that.
Yes. For as I told you before, I mean, for the loose fruit, for the loose peel fruit, the oil extractor, the polycitrus oil extractor, is not the optimal solution because you can destroy the fruit. So there are also other opportunities for that to extract that kind of oil.
Correct.
We can customize your line according to your needs. So we do not sell you or propose you a standardized line, as you can see around the market at the moment, but we can customize it according to your needs, with the machines that you need, with the disposition of the machine that you need, and so on.
Yeah. So these are some of our upcoming webinars. So all the attendees will receive the notification for registration as well. And you can see our past webinars on our YouTube channel. Also, you can visit Neologic website, wherein you can watch all the previous webinars on demand. Yeah. So also, I would like to give a heartfelt thanks to our esteemed speakers, Mr. Carmelo and Mr. Sri Krishna Ozarkar, for sharing their profound insights into citrus fruit processing technologies. And we extend our gratitude to Fratelli and Indelicato for collaborating with us to make this 19th webinar a success. And finally, sincere thanks to all the attendees for your active participation and engagement. Let us continue driving innovation and excellence in food processing, and we look forward to see you in the future webinars. Thank you once again for joining.